Hello, my name is Isaac, and this is a Physics 2211 Lab 2, Motion of a Falling Object. The goals for this lab was to observe the motion of an object in freefall, and to code a model in which that graphs the object's motion without drag force, as well as with drag force. The outcome was that the model without drag force dropped too far, and the model that did have drag force dropped a little bit less than the observed. The assumption is that motion was only in the y-axis. The key concept here is Newton's second law. It states that net force is a change in momentum over time, and this can be used to update the velocity formula. So final velocity equals initial velocity plus F net over the mass of the object times the change in time. It can also be used to update the position formula. So final position equals initial position plus average velocity times the change in time. Another key concept is gravitational force, or the force near Earth's surface, which is mass times gravity, and gravity near Earth's surface is 9.8 meters per second squared. Another key concept is drag force. Drag force opposes the motion of the object. It is caused by the object hitting air particles. The equation is drag force equals negative b times velocity squared times unit vector of velocity. And here's the object used in the lab. Here's the coding for the initial conditions. So the ball's mass was 190 grams. The initial position and velocity was all 0, and the only thing that changed for between the two codes was that b equals 0 for without drag and b equals 0.19 with drag. So this is more of the coding. Without drag, everything is the same except for F net. Here F net is a vector in which it is mass times gravity, and here F net is the weight, or mass times gravity, plus the drag force, which is that equation shown earlier. Here are the results. Without drag force, the object way overshot the intended mark, which is negative 1.813. And with drag, it got just under. Here is the video. Here's the tracker results. So tracker got negative 1.813. Here's the differences between all the graphs. So they all start at 0. The velocity, or the position for the model, is the same, but the one without drag went way over, and the one with drag and observed and predicted is about the same. What does this mean? The model that includes drag force predicts terminal velocity. Terminal velocity is the maximum speed of an object that an object can get to, where the force of gravity on the object is equal to the drag the object causes. Because the force of gravity and the force of drag is equal, the net force will be 0. Here's the graph to prove it. You can see here that the velocity is hitting a barrier at around negative 3.2 meters per second. What if? So here it is shown that an object at rest will have a lower terminal velocity than an object that is already in motion or thrown. Here you can see it's negative like 3.1. Here it is negative 1.5. So it is more. Some possible errors in the code, or some possible errors, was that I did not know the mass of the object. So I was just guesstimating. And the b in the drag force equation was not known, so I just tried to match the predicted position with the observed position as best as I could. I may have also not tracked the object as well as I could have in Tracker, leading to possible errors in the predicted position in the observed position graph.